Many people within the bodybuilding industry, even within the high-intensity training community, dismissed Mentzer's remarks as half-baked and unscientific theorizing. But others realized that what he was saying was ahead of his time. At the heart of his philosophy was the indirect effect, the idea that stimulating growth in one muscle, especially the body's largest muscles, sends a cascade of signals throughout the organism, creating an environment for adaptation everywhere. The true target of training, then, was not just local hypertrophy, but the activation of the entire biological machinery of growth. Decades later, with modern discoveries about hormones, myostatin, and myokines, Mentzer's insights looked less like heresy and more like prescience. To see why, we need to explore both Mentzer's reasoning and the science that now confirms it. The indirect effect, from observation to principle. Arthur Jones, the maverick inventor of Nautilus machines and one of the most provocative figures in strength training, first articulated the indirect effect in Nautilus Bulletin No. 1, which was published in 1970. Jones wrote, quote, "When one muscle grows in response to exercise, the entire muscular structure of the body grows to a lesser degree, even muscles that are not being exercised at all. And the larger the muscle that is growing, or the greater the degree of growth, the greater this indirect effect will be." Close quote. Jones had noticed that young men who trained heavily with squats often grew everywhere, not only in their thighs. Some lifters added 50 pounds of muscular body weight in a year, with noticeable gains in the chest, arms, and shoulders, despite little direct arm work. From these observations, Jones concluded, 1. Growth in one muscle stimulates growth elsewhere. 2. The larger the muscle mass trained, the greater the ripple effect. 3. Training should prioritize large muscles first, legs, lats, traps, then smaller ones. For Jones, the indirect effect was undeniable but mysterious. He admitted that he did not know why squats and deadlifts had such widespread effects. His focus was practical: train the whole body in one workout, starting with the largest muscles and finishing with the smallest, so that the systemic effect of big muscle training wasn't diminished by fatigue. Mentzer began articulating the indirect effect in the late 1970s and 1980s, arguing that growth in large muscles stimulated growth throughout the body. By the early 1980s, he was explicit, quote, "To get the most out of your triceps training, it's logical to train your legs as hard as possible since, being the largest muscles in the body, their growth will have the greatest effect on stimulating growth indirectly in the rest of the body." Close quote. The real goal was not to grow quads or pecs in isolation, but to switch on the body's growth machinery. Once the switch was flipped, the entire organism adapted. From this insight came two breakthroughs: exercise selection. The best tools were compound, multi-joint movements that recruited massive muscle groups. Squats, deadlifts, pull-downs, dips. These created a more profound setting for the indirect effect than small, localized lifts. Recovery paradigm. If growth was systemic, then recovery also had to be systemic. It was not enough for one muscle group to feel recovered. The entire organism had to repair and adapt.
I'm not talking about localized muscle recovery. I'm talking about recovery of the physical system as a whole. Localized muscle recovery actually takes place very rapidly. But you do 10 sets of squats, very, very heavy squats on Monday. Your legs may have recovered by Tuesday, but try to do a heavy back workout on Tuesday. You won't feel the inclination because your whole system has been called upon. Demands have been made upon all the body's recuperative subsystems, not just the leg. The whole system is called upon. You've got to allow the whole body to recover, not just the legs.
This insight led Mentzer to abandon Jones' thrice-weekly full-body training and eventually to develop the consolidated program. 2 compound exercises, 1 set each, performed to failure, and then rest for as long as it took, often 5 to 9 days, before repeating. Where Jones had emphasized sequence and frequency, Mentzer emphasized intensity and sufficiency. By stripping training to its systemic essence, he reframed the indirect effect from a curious observation into the foundation of a minimalist, evidence-driven philosophy. What others treated as anecdote, Mentzer treated as principle. His claim was clear: train the biggest muscles with enough intensity to failure, and the whole organism will respond. Exercise was not localized stress, but a systemic trigger. Failure as the key to activation. Mentzer emphasized that training to momentary muscular failure was the non-negotiable requirement to flip the switch.
Only one set of an exercise carried to failure is all that is required to stimulate an optimal increase in strength and muscular size. The last rep is the rep that causes the growth machinery to go into motion.
Here, science aligns. Muscle contraction is not a random process. It follows a biologically programmed sequence. The body does not simultaneously activate all available muscle fibers during exertion. Instead, it recruits them in an orderly progression based on force demands. This pattern, starting with fatigue-resistant, low-force, slow-twitch fibers, and ending with the powerful, growth-prone, fast-twitch fibers, was empirically validated by Elwood Henneman, whose seminal research introduced what is now known as the size principle. In his groundbreaking 1957 study, Henneman demonstrated that small motor neurons are recruited first, and larger, high-threshold motor units are only activated as greater force is required. This sequence occurs not arbitrarily, but due to the intrinsic electrical properties of motor neurons. Smaller ones are more excitable and therefore fire earlier. Subsequent studies by Henneman and colleagues in the 1960s further confirmed that this sequential recruitment is the nervous system's default strategy for managing effort, precision, and energy efficiency. A recent study adds modern weight to this claim. Researchers compared single-set training to failure with training that stopped with 2 repetitions in reserve. Both groups improved, but hypertrophy tended to favor the failure condition. In other words, the last grinding reps, the ones that force full fiber recruitment, are precisely where the difference emerges. This is exactly what Henneman's size principle predicts. For Mentzer, the heavy breathing, lactic acid burn, and oxygen debt of the final grinding reps were not signs of exhaustion alone. They were the very markers of systemic activation, the point where the indirect effect was maximized. Training to failure guarantees full fiber recruitment. That last possible rep, not the first, is the one that ensures the body-wide growth signal is sent. The science behind the indirect effect. In the decades since Mentzer first referenced the body's growth mechanism, science has caught up. Today, exercise physiologists routinely describe skeletal muscle as an endocrine organ, meaning it secretes proteins and chemicals that affect tissues throughout the body. 1. Myostatin suppression. Myostatin is a protein encoded by the GDF8 gene, growth differentiation factor 8. It acts as a brake on muscle growth, preventing unchecked hypertrophy. Animals or humans with defective myostatin genes often develop unusually large muscles, illustrating its powerful inhibitory role. Resistance training has been shown to suppress myostatin expression with effects that extend systemically. A study by McKenzie et al. Demonstrated that acute resistance exercise inhibits myostatin signaling via the Notch pathway. A study by Laurentino et al. Showed that blood flow-restricted resistance training reduced myostatin gene expression, pointing to systemic suppression. Because myostatin circulates in the bloodstream, reducing it lowers the barrier to growth across the entire body, even in untrained muscles. 2. Hormonal cascades. Resistance training provokes robust endocrine responses. These involve hormones released into the bloodstream that travel to distant tissues rather than acting locally. Kramer and Radamus, in 2005, showed that compound lifts trigger surges in testosterone, growth hormone, and insulin-like growth factor 1, also known as IGF-1. Kramer et al. In 2020 confirmed that these hormones interact with cortisol and other factors to regulate cell growth and recovery system-wide. This is the biochemical reality behind Mentzer's growth mechanism. A hard set of squats is not leg work, it is a whole-body hormonal event. 3. Myokines as messengers. Beyond hormones, contracting muscles release signaling proteins called myokines. These are sometimes referred to as muscle messengers. Unlike classical hormones that come from glands, myokines are released by working muscle fibers themselves and can affect metabolism, immunity, and growth. Zunner et al. Described myokines such as IL-6 and IL-15, which stimulate satellite cell activation, that is, muscle stem cells involved in repair and growth, and reduce inflammation. Kanzleiter et al. Identified decarin, a myokine that binds directly to myostatin, neutralizing its growth-suppressing influence. Miura et al. In 2006 confirmed decarin's role, showing that it binds to mature myostatin in a zinc-dependent manner. That is, zinc was found to be like a molecular glue that allows decarin to latch onto myostatin and neutralize its suppressive effects on muscle growth. In other words, decarin reduces myostatin's inhibitory effect on muscle precursor cells. Again, the signal does not stay in the trained muscle, it spreads systemically. Cross-adaptation. Perhaps the most striking demonstration of the indirect effect in the scientific literature is the study by Hansen et al. In 2001. In this experiment, all subjects trained one arm. One group also trained their legs during the same sessions, while the other group performed only arm training. In the leg and arm group, the trained arm increased in strength by 37%, and the untrained arm, which received no direct work, improved by 10%. In the arm-only group, the trained arm gained just 9% and the untrained arm only 2%. This means that training the legs not only boosted the trained arm's results, but also produced greater improvements in the untrained arm than direct arm training alone. The only possible explanation is systemic. Training the large muscles of the legs created a hormonal and molecular environment that spilled over, enhancing adaptations in tissues that weren't even exercised. Are isolation exercises necessary? Critics often claim that abandoning curls, extensions, and flies leaves the smaller muscles underdeveloped. Mentzer disagreed, and science supports him. Rogers et al. In 2000 found no additional growth when isolation movements were added to compound training. Bottaro et al. In 2013 confirmed that single joint work added nothing to hypertrophy in untrained men. Steele et al. In 2015 extended the finding to trained individuals. Genetics, high responders, and low responders. No training philosophy can be understood apart from genetics. Mentzer was adamant that one's genetic ceiling is the ultimate determinant of physique potential.
So this is a seminar not to guarantee you a Mr. America physique or a 20-inch arm, but what I'm offering with this seminar is a new perspective which will change your entire outlook of the sport of bodybuilding and hopefully help you to reach the limits of your individual potential in the shortest time possible. Whether that potential happens to be as great as Arnold's or only good enough to become the best-built man in your backyard.
Modern science confirms this. Models of natural hypertrophy show that most trainees gain the bulk of their muscle in the first year, with rapidly diminishing returns. Some individuals, high responders, grow dramatically, while low responders add little despite the same program. Genetic factors like myostatin expression and androgen receptor density explain these differences. Studies reveal enormous variance in adaptation, with some subjects gaining strength and muscle rapidly, while others show minimal changes. For Mentzer, this underscored the importance of efficiency over volume. More sets do not change your ceiling. For high responders, minimal training suffices. For low responders, extra volume only deepens the recovery deficit without changing the outcome. Steroids and the illusion of volume. Perhaps the most misunderstood aspect of bodybuilding culture is the role of drugs. Mentzer was forthright. professional physiques were inseparable from pharmacology. A landmark study by Bashan et al. In 1996 showed that testosterone alone built more muscle than resistance training alone, and that combining the two produced exponential gains. In fact, men given 600 milligrams of testosterone weekly without exercise gained more muscle than men training hard without drugs. Mentzer summarized it sharply.
Steroids act primarily as recovery ability enhancers. Were those same bodybuilders to train for 2 hours a day, 6 days a week without steroids, they would begin to lose muscle mass almost immediately.
This explains why elite bodybuilders can thrive on marathon routines. Drugs suppress myostatin, supercharge recovery, and extend genetic ceilings. For natural trainees, attempting to copy these programs is counterproductive, leading to stagnation or regression. Mentzer never tired of reminding audiences.
Remember, science is an exacting discipline. There's no room for the arbitrary in science.
The comparison between enhanced and natural lifters is arbitrary. The rational approach is to design programs around natural biology, intensity, systemic stimulation, and respect for recovery. Recovery as the bottleneck. The indirect effect makes training a binary switch. Either the growth mechanism is triggered or it is not. Once triggered, additional sets add no further signal, they only add fatigue. Science affirms this. Muscle repair follows a process akin to wound healing, requiring days, not hours, for inflammation to subside, proteins to rebuild, and supercompensation to occur. Training again too soon interrupts the cycle, forcing the body back into repair rather than growth. Perhaps the most decisive confirmation of Mentzer's philosophy comes not from anecdote or short-term trials, but from large-scale, longitudinal data. In 2022, Steele and colleagues published a retrospective study in Research Quarterly for Exercise and Sport that followed 14,690 participants over 7 years. The program was deceptively simple. Once per week, participants performed a single set of 6 compound, machine-based exercises, such as chest press and leg press, always carried to momentary muscular failure. The participant pool was diverse, making the results broadly generalizable. The results of the study were striking, and several themes emerged that resonate deeply with Mentzer's long-held arguments. Rapid early gains. Within the first year, chest press strength increased by about 30%, and leg press strength by about 40%, aligning with the well-established beginner gains phenomenon. Asymptotic growth curve. Progress slowed but never stopped. By year 7, chest press strength had increased by around 50%, and leg press by around 70% over baseline, an unmistakable long-term upward trajectory. Broad applicability, sex, age, and body weight had little effect on outcomes. The constant was not demographics, but intensity. Every participant trained to true muscular failure. Long-term durability. The most striking finding was sustainability. Across nearly a decade, participants not only retained but steadily expanded their strength gains, showing that minimalist training is not a hack, but a lifelong solution. Why this matters? Steele et al.'s study provides population-level confirmation of what Mentzer argued decades earlier. The indirect effect is real, and once the systemic growth switch is flipped, the body adapts globally. Systemic adaptation. Even at once-weekly frequency, failure training triggered hormonal, molecular, and genetic cascades, precisely the same systemic signals Mentzer emphasized. Recovery as the bottleneck. The once-per-week design respected the natural recovery timeline identified in classic muscle damage studies such as Clarkson et al. In 1992 and Smith in 1991. With 5 to 7 days of regeneration, participants consistently adapted instead of stagnating or regressing. Minimal effective dose confirmed. Beyond the threshold of triggering the growth mechanism, Additional sets, exercises, or sessions were unnecessary. The smallest effective dose, one set to failure per muscle group per week, proved sufficient to drive progress for years. This dataset is historic in scope. Never before has such a large, long-term population demonstrated the viability of Mentzer's minimalist high-intensity paradigm. What began as a logical argument now stands as a scientifically validated training philosophy. By the end of his career, Mentzer framed his philosophy as a rejection of bodybuilding myth.
We've been asking the wrong question all these years. The question should not have been, how much exercise do we need, but how little do we require?
This reframing is profound. If exercise is about flipping the systemic growth switch, then more sets, more days, and more movements are not productive. They are redundant. The real art lies in identifying the minimum effective dose that stimulates the mechanism, and then allowing the body the time it needs to adapt. Conclusion: ahead of his time. Mike Mentzer's articulation of the indirect effect was once mocked as extremism, dismissed by both the mainstream bodybuilding public and even by some of those within the high-intensity training community. But with modern research into myostatin, hormones, myokines, and genetic variability, it stands as a scientifically defensible model of training efficiency. Growth is systemic, not local. Isolation work is unnecessary when compound lifts are taken to failure. Genetics and recovery ability, not volume, determine ultimate progress. Steroid use explains the illusion of high-volume success, while naturals must train within their biological limits. What was once dismissed as heresy now reads as foresight. Mentzer may not just have been ahead of his time, he may still be ahead of ours.